Hello students, welcome to Engineering Mechanics course. In this class we will see one more problem on equilibrium of concurrent force system. So the statement of problem is four wooden members are joined with the metal plate connectors and are in equilibrium under the action of four forces as shown in figure. So this is rectangular metal plate where these four wooden members are connected, inclined members. This system is in equilibrium, it is given to you under the action of these four forces. Knowing that Fa equal to 1.9 kilonewton and Fc equal to 2.4 kilonewton. So Fa force and Fc force magnitudes are given to you. Question is to determine the magnitudes of the other two forces, that is Fb and Fd. These two forces we have to determine if this system is in equilibrium. So with reference to previous lecture, we know that very first step is to draw the free body diagram, right? Draw free body diagram of the given system of force. So forget about this metal plate and the wooden members, draw only forces at this point of application. Okay, so this is free body diagram. So these all four forces, if you look at the figure carefully, all four forces are push type of force, right? So it means Fa, which is given in the second quadrant, it looks like second quadrant, but since it is a push type, actually the force is going in the fourth quadrant. Similarly Fb, which is shown in the first quadrant, but it is going in a third quadrant. Fc shown in third quadrant, but it is going to the first quadrant, and Fd shown in the fourth quadrant, but it is going to in the second quadrant. So all four forces are push type, and using principle of transmissibility you can actually imagine the quadrant where these forces are acting. Okay, so these are the four forces shown with the blue color. Now according to the corrected quadrant of that force, that Fa is in fourth quadrant, so we have resolved this force into xy components. So fourth quadrant means x component is plus, y component is minus. Angle with respect to horizontal is given 30 degree. Okay, this is 30 degree angle. So horizontal component cos, vertical component sine. So x component is Fa cos 30, y component is minus Fa sine 30. Downward means minus. Similarly Fb, which is in the third quadrant, it is going in third quadrant, so x component is minus, y component is also minus. The angle of Fb is also 30 degree with respect to horizontal, so x component is Fb cos 30, y component is Fb sin 30. The Fc force, it is making an angle of 45 degree with respect to horizontal, which is given to you. Fc force is going in a first quadrant, so x component is plus, y component is also plus, Fc cos 45, Fc sin 45. Similarly the last force Fd, which is in the second quadrant actually, so angle is 45 degree. Second quadrant means x component is minus, x component is minus, this is not plus, x component is minus, y component is plus, Fd cos 45, Fd sin 45. So all four forces are in inclined direction, so all four forces we need to resolve to write down the equations of equilibrium. Now since it is given the system is in equilibrium, this is given to you, and we know that for the solution, if body is in equilibrium, it means summation of Fx 0 and summation of Fy 0. Collect the forces which are in x direction and collect the forces which are in y direction, equate those with equal to 0. You will get two equations. So first, if you collect those forces, this is summation of Fx equal to 0, first equation, and this is summation of Fy equal to 0, second equation. So summation of Fx, Fa cos 30, it is plus towards right, Fb cos 30 minus towards left, Fc cos 45 plus towards right, Fd cos 45 minus towards left. So plus minus plus minus, Fa cos 30, Fb cos 30, Fc cos 45 and Fd cos 45. First equation. Similarly collecting the forces which are in y direction, FA sin 30 is minus because downward, FB sin 30 is also minus because of downward, FC sin 45 is plus because upward, and FD sin 45 is also plus upward. So we have written these two equations. Now if you simplify these two equations by calculating the values of sin 45, cos 45, sin 30 and cos 30, we will get these values. Cos 30 is 0.866, cos 30 this is, cos 45 is 0.707. Okay, similarly sin 30 is 0.5 and sin 45 is 0.707 again. And now since FA is given to us 1.9 kilonewton, we also put the value of FA 1.9 and FC is given as 2.4. So if you put all values of FA and FC values 1.9 and 2.4, and at the same time if you put the values of sin 30, cos 30, sin 45, cos 45, you will get these two equations. If you simplify these two equations again, the value of this 1.9 into 0.866, it is coming 1.6454, and 2.4 into 0.70, it is coming 1.6968. Similarly in the second equation also, if you calculate these values, we have simplified these two equations again. Okay, next step again, if you simplify now, if you take summation of these two known values, okay, and if you take this FB and FD, if you take these two terms on the right hand side, it changes its sign. FB becomes plus in first equation and FD is also plus. Similarly in second equation, when FB goes to right hand side, it is plus and FD term will be minus, and if you add these two known values, it will gives you right hand side constant. So if you simplify this again, you will get this equation. This is 0.866 FB and 0.707 FD, right, and both are minus. If you take on either side, right side, it become plus, and this summation is coming 3.3422. Similarly in second equation, this sign become plus and this plus become minus, and minus 0.95 plus 1.6968, the answer is coming 0.7364. And now if you put these two equations in your calculator and solve two equations, two unknowns, you will get value of FB and FD. So those two values are, after solution of these two equations, that values are coming FB equal to 2.986 kilonewton and FD equal to 1.070 kilonewton. So these are the values of two unknown forces using conditions of equilibrium. I hope all of you have understand the solution of problem. Thank you very much.